Hi, welcome to another lecture on business mathematics. We talked about factoring polynomials in the last lecture. Uh, Today we are going to talk about finding roots of polynomials. Let's see uh, why is this thing important and how are we going to do it. Okay, first issue is, well, we learn how to factor. These are the examples of what we did last time. Now we want to know how do we find roots of polynomials or roots of equations. Well, typically a root refers to a particular value of the unknown variable which makes the function to have a particular value, namely 0. Now, why do we care about a polynomial becoming 0? An example that's rather easy to see is the example of throwing a ball into the air. If we throw a ball into the air and for the moment ignore the complication of air friction and such, the ball is going to travel in a trajectory that looks to be very close to kind of polynomials we had seen before. That is, it's going to be a second order quadratic equation. So when we are tracking this ball, what do we care about? One is how high it has gone. So the elevation of the ball as it goes through its trajectory, it changes. Eventually the ball is going to strike the ground. Well, what happens there? Ball striking the ground means the height above the ground has turned into 0. So if you want to find out where or when the ball is going to hit the ground, you are going to solve an equation where you get the height of the object and set it equal to 0, and then you solve it. Well, that is exactly finding roots. When you want to find roots, we are setting a function equal to 0, find out when that happens, and in this instance it's going to show us when it strikes and perhaps where it got off the ground. So 2 points perhaps are going to be found. Well, what does that have to do with business? I mean, it might be interesting for throwing a ball, and if you're a football player, maybe you're going to care about how to solve that, but how does that relate to business? Well, the functions that we study, they have a very wide range of applications. So you could be showing the profit of a company, and of course you want the profit, you want to make money, you don't want to lose money. So break even is when you are going to reach 0 level. So if the profit of a company was behaving like this curve, then you will be interested in knowing when that happens. When did this one happen? So something becoming 0 is essentially finding how to a strike is going to happen. How does one quantity equals to some other quantity? That's essentially the main topic we are after. Now let's start very simple. So we want to learn how to find the roots of equation. Let's have a very simple equation. Suppose I have x squared plus x, and I want this thing to be 0. So the question is, what value of x placed here will make this thing equal to 0? The big idea that is applicable in all these problems is that if the product of two numbers is 0, at least one of them has to be 0. If I have a number and I have another number and the product of them is 0, if a times b is 0, then we can conclude that a is 0 or b is 0. Or perhaps it could happen both of them are 0. But at least one of them got to be 0. Similarly, if you have product of three numbers equal to 0, then you can conclude that either A is 0, or B is 0, or C is 0. Some exceptional cases, perhaps 2 or 3 of these things could happen. But when we have a product of few numbers is 0, at least one of them is. So that idea leads to the following. If I have a polynomial equal to 0, I go ahead and factor it. And factoring it means writing as a product of a few things. And then I'll set each of the factors equal to 0. And that would be easier to handle than the original one. So here the factorization, we learned that I can factor simply an x out of here. It becomes x times x plus 1 and still equal to 0. So what does our great idea say here? Say if product of two things is 0, at least one of them got to be 0. So either the first one is 0, so this is the first one, or the second one is 0. Here is the second one. So the first one is equal to 0. Well, there's nothing special to do there. It's just already solved the equation. How about the second one? Well, we add a minus 1 to both sides, or move 1 to the other side, and I get x equals to minus 1. So x is either 0 or it is minus 1. These are referred to as roots or solutions, sometimes zeros, a variety of names, roots, solutions. Sometimes it's called a 0 because it makes something to be 0. If you were to graph this thing, like I encourage you to go ahead and graph it on, say, Desmos, x times x squared plus x, the graph of it is going to look like this. And when you look at that, you see you struck the x-axis at 0, and the other striking point was minus 1. So graph of this is the graph of y is equal to x squared plus x. These are the 2 points where it strikes the x-axis. We call them the x-intercepts. You remember we call these things x-intercept because that is when the picture strikes the x-axis. Let's try another one. Suppose I have x squared plus 5x plus 6 equal to 0. I want to find x's that makes this a true statement. We said, what do? We factor this thing. Remember how we did that? Find two numbers such that the product is 6 and sum is 5. We did this thing last time. We found out that the answer is x plus 2 times x plus 3. Now we appeal to the following idea that if product of two numbers is 0, at least one of them has to be 0. Either the first one is 0 or the second one is 0. Now these are simpler equations than that one was. That's the idea of factoring. I'm dealing with a much simpler equation. I can easily solve it. X equal to minus 2 or x is equal to minus 3. So that becomes solution of this one. Here's another example. X squared plus 6x plus 9 equal to 0. We learned the factorization of this last time. Two numbers such that the product is 9 and sum is 6. That's just 3 and 3. So it becomes x plus 3 times x plus 3. So either the first one is 0 or the second one is 0. So either x is equal to minus 3. The other equation gives us exactly the same number, which makes the final answer look rather odd looking. X is either minus 3 or x is equal to minus 3. We cannot just say the root is minus 3. We have to kind of flag the fact that there are two of them, and by this peculiar coincidence they turn out to be the same. Like for example, you have kids and the kids happen to be twins. You don't say, if they happen to be identical twins, you don't say I have one kid just because they look like each other. In mathematics also, when the number shows up several times, you have to indicate it. You have to say, well, I have twins, I have the identical twins or triplets and so on. Maybe God blessed you with 8 kids. Then you have to kind of indicate that there are so many kids and perhaps they look like each other. So here's official way of doing this thing in mathematics. We say root is -3 has multiplicity 2. Just like with the kids, they refer to tuples, maybe triplets, quadruplets, and so on. Here we have 2 of them, and it be indicated by saying multiplicity 2 as a rather big word. Sometimes we simplify it. We refer to it as a twin roots -3 or double or some other fact that is going to indicate that we had 2 of them. It just happened that they are the same numbers. Okay, moving on. Sometimes we have a bit more work to do. For example, we did this thing last time. We've worked with the factorization. Now we're finding the roots of it. So I'm looking for 2 numbers such that the product is -24 and the sum is 2. Last time we explained that this number, x plus 6 and x minus 4, our roots are going to have the opposite signs. That is, either x is from the first one we get -6, from the second one we get 4. I didn't bother to write this prior step of it, like we were writing it and then solving it, but by now we understand that so if you can go a little bit faster, that would be great. So x plus 6 is equal to 0, and that gives you this one, and x minus 4 equal to 0, that gives you that one. So remember, first we factor it so that our job will be easier, and then we set each of the factors equal to 0 and solve it by methods we learn how to solve the first order equation, and so on. Next example was a bit more challenging. For example, we had 2x squared plus 7x plus 3. We learned how to factor it, and then now we are going to solve it. How did we proceed? Remember, we said take the first and last numbers and multiply, becomes 6. So product, I want product to be 6, and I want the sum to be 7. Well, what are 2 such numbers? Obviously 6 and 1. Then rewrite this as 2x instead of 7x. Write it as 6x plus 1x. So this is how we broke down that 7x plus 3. Then you do factorization by grouping. The first 2, I can factor a 2x out of it, was x plus 3. And the last 2, just there's a factor of 1. It's a factor of 1. Then x plus 3 is the common factor, so I write x plus 3 times 2x plus 1 equal to 0. So when that is the case, I'll have 2x plus 1 equal to 0, or x plus 3 equal to 0. First equation tells you that 2x is equal to -1, therefore x is equal to -1/2. And second one tells you that x is equal to -3 already, so that is the root of that problem. So if we could factor easily, then that is the final, the main step in the solution and then we can get the roots. Sometimes, however, our problems are not as easy as the ones that we just did. Sometimes we come across something that does not factor easily. What are we going to do then? Look what? Suppose I tell you x squared plus, say, 7x plus 1 is equal to 0, and ask you what is the root of this? Well, we cannot think of two numbers such that the product is 1 and the sum is 7. Not easy to come up with these numbers. What do we do then? Well, these problems were solved as far back as perhaps 2,000 or 3,000 years ago, and we are essentially following the same blueprint for solving them. This is a general case of a quadratic equation, and you might have seen this in your prior classes. We are going to do that. So we are going to bring some big guns. That is, I have some number. Let's see. Ax squared plus bx plus c equal to 0. This has a big name. It's called quadratic. Quadratic simply means degree 2. Quadratic equation or quadratic formula. So the idea is that if I have some arbitrary numbers in my problem, chances are very high that I cannot succeed in factoring by looking into these whole numbers and doing the things we learned. What do we do then? Rather simple and rather ingenious. Applies to this case. Step 1, put the c on the other side. So it's going to become minus c. Subtract the c from both sides. Step 2, multiply both sides by 4a. So 4a, I'm going to multiply it by what I had on the left, and I'm going to multiply it by whatever I have on the right. Okay? We are multiplying two sides of an equation by the same number. So long as the number is not 0, you're fine. Okay, now multiply through, becomes 4a squared x squared plus 4abx. And on the right hand side, I have minus 4ac. Now I look at the left hand side and I say it reminds me of something. Reminds me of what? If I had 2ax plus b, if I had 2ax plus b and I wanted to square it, I'll get the square of the first one, which is 4a squared x squared, twice the first and second, which is 4abx. But then I will also get a b squared, so I'm missing that. So I'm going to go ahead and add that to both sides. So I'm going to add b squared here and b squared there. So what does that do? It makes my right hand side become b squared minus 4ac. Now what? Left hand side is so-called completed square. Okay, we became completed square. What's the advantage of that? Advantage of this is that I can take square root of it. So I can say 2ax plus b. Well, when you take square root, for example, when you're solving, say, y squared equal to 25, what do you say? So y can be 5, y can be minus 5, is that right? To compress, you write it as y is equal to plus or minus 5. Here, same way, say plus or minus, whatever this thing is, I have to take square root of it. Now I take b subtract it from both sides, so it becomes 2ax is equal to minus b plus or minus b squared minus 4ac. And then my x becomes minus b plus or minus radical b squared minus 4ac divided by 2a. This is the celebrated quadratic formula. That is, instead of going through factorization, finding the roots little by little, you have this ready-made formula that brings you the final answer quickly. Let's go back to that problem that we had, and we had a hard time with factoring it. Let's try this style. So first of all, what are my a, b, c? In front of x squared, if there is nothing, it means my a is 1. This is my a, this is my b, this is my c. So what does the formula say? X is equal to minus the middle term, minus 7, plus or minus 7 squared, minus 4 times the first number a and the last number 1, divided by twice the first number a. So it becomes minus 7 plus or minus. That is 49 minus 4 over 2. We clean up a bit. Becomes minus 7 plus or minus square root of, that is 45 divided by 2. Can I simplify this? Well, just a bit. 45 is 9 times 5. So square root of 45 is going to be square root of 9 times square root of 5. And that is 3 square root of 5. So if you like that bit of simplification, you can do that. So my roots, I have two roots. Let's call it roots with a plus and roots with a minus. So root plus is minus 7 plus 3 radical 5 over 2. And the root with the minus 7 minus 3 radical 5 over 2. So then we can find, if you want to, we can do factorization. Is x minus one root and x minus the other root. But the idea was that you can get two roots, and that is how to do it. Let's do another example. Suppose I have, say 2x squared minus 5x plus 3 equals to 0. I can try to do it by factorization we learned before. But sometimes those factorization methods could actually take a long time, and with the trial and errors that involved. In this case, not necessarily so, but it's possible. The idea is that across all cases, you can use the quadratic formula. Let's write it again here. So x was minus b plus or minus b squared minus 4ac, and then divided by 2a. This was a, this with the sign is b, and this one is c. So x will be minus b. So b is itself minus 5, minus b will be 5, plus or minus. Then b squared, always use the positive here because you're squaring anyway, minus 4 times the first number and the last number. The whole thing divided by twice the first number. First number was 2. So it is 5 plus or minus 25. This is 24. This is 25 minus 24. Then divided by 4. Here we got lucky that we got easy number under square root. Easy meaning square root is a whole number. So I get 5 plus or minus square root of 1 is just 1 divided by 4. Let's write this thing separately. X is either 5 plus 1 over 4, which is 6 over 4, and that's easy to write it as 3 over 2. Or x is 5 minus 1 over 4, which is 4 over 4, and that is just 1. So we got our roots 3/2 and 1. Let's remind ourselves that we could have factored this thing rather not too difficult, but in this case would have been fast. So what was our old style? Old style of doing this thing was take first and last numbers and multiply them by to get 6. Now give me two numbers such that the product is this number 6, and the sum is that middle number minus 5. What are two numbers such that when you multiply it you get 6, and when you add them you get minus 5? Well, what are possibilities for 6? It's either 1 and 6, or 2 and 3, or 3 and 2, or 6 and 1. Or it's minus 1 and minus 6, or minus 2 and minus 3, or minus 3 and minus 2, and minus 6 and minus 1. Which one of them sum is 5? Well, these are the only possibilities. Pick either of them, it doesn't matter. 2x squared. So instead of minus 5x, I write minus 3x minus 2x, and then I write 3. So our trick last time was to break that middle one in this fashion. Now the first two, I can factor an x out of it. I get 2x minus 3. The second two, I factor a minus 1 out of them. I get 2x minus 3. Okay, so I'm setting these are equal to 0. I factor 2x minus 3. Either the first factor is 0, x minus 1 is 0, or the second factor is 0, 2x minus 3 is 0. So this one gives you x equal to 1, and this one gives you x equal to 3/2. These are exactly what we got previously. These are the same things if you notice. So we learned how to factor. We paid tribute to this major idea from ancient times, how to solve the quadratic equation. So let's paraphrase that one more time. So the important thing we learned today was if you have ax squared plus bx plus c equal to 0, so x squared and then x and then 1, then x was equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Of course, if we pay attention to what is under square root, we can detect three cases. If this is positive, or 0, or negative. If it is positive, then we'll have two different roots. If this is 0, both roots are equal to minus b over 2a. And if this is negative, then our roots are not the real numbers because square root of a negative number cannot be an ordinary real number. So that becomes a so-called complex number. We are going to put that aside for now until we come back to it perhaps at a later time. So right now we learn how to factor quadratic equations and how to find their roots, and we learn about the quadratic formula. We briefly talked about three possibilities: b squared minus 4ac being positive. We result into two distinct real roots. If b squared minus 4ac happens to be 0, this radical becomes 0. Both roots are minus b over 2a. That's a case of identical, let's say, identical roots, or twin roots, or root of multiplicity 2. And if b squared minus 4ac happens to be negative, we are taking square root of a negative number. The result is something called complex number, which we are not going to pursue right now. So that was the main result today. And in the next lecture, we are going to see how to do the same thing with a software like Desmos, how we can look at all of this results on that software. Okay, until next lecture, good luck and God bless.